Hey, good afternoon, everybody. Thank you for coming in. Go ahead and get started. This is SAC307, the Psychology of Security Automation. I'm Jason Chan, and I lead the cloud security team at Netflix. So just real briefly, in terms of what to expect today, if I was going to just describe it in one line, this would probably be what it is. I want to provide an inside look at how we think about security automation at Netflix. I know when I go to reInvent or pretty much any conference, the talks I tend to like the most are the ones where people talk about what they're doing in the real world, how they solve actual problems. So that's kind of how I tend to do my talks. Netflix has been using AWS for a while now. I've been at Netflix for closing in on about 6 years. So I have spent a lot of time thinking about cloud security, how to build security tools and security automation, and what makes those successful. And then pretty much everybody, whenever you talk about AWS or you talk about moving to the cloud, security tends to be one of the topics that comes up, right? People ask, what's different about security in the cloud, or what do I have to worry about? What changes? And those are all good questions. What I've been hearing more recently, maybe the last year or so, is more and more people are starting to say security can actually be better in the cloud. If you move to the cloud, you can do things differently. And what I want to dive into more is like what specifically about AWS can unlock new capabilities. So I want to talk about that. And then just generically, over years of building some of these tools, what I have seen kind of bubble up to the top is a set of design principles that a lot of successful security automation tends to share. And these principles tend to both improve security as well as improve the relationships between security teams and developers. And that kind of brings us back to the title of the talk. Because the more I work in engineering or technology or security, the more I really believe that the solutions to our most difficult problems are pretty much multidisciplinary in nature, meaning that a really hard technical problem, you're not going to solve it just with technology, right? There's a human element to it. That's why fields like UI, UX exist. They want to capture those human dimensions of the solution and make sure they get implemented appropriately. So I want to talk about the human element. I also want to bring in one extra thing, and that's history, or maybe more specifically, shared history. And the history that I want to talk about is the history of relationships between developers and security teams. So I have been in security pretty much my whole career, have also produced a lot of software. I imagine many folks in this room probably consider yourself either a developer or a security person, or maybe both. And really, if I were to try to describe those relationships, frankly, they've been pretty problematic, at least in my career, kind of prickly, complicated, kind of intense sometimes. And we want to talk about why that happens and what we can do about it via thoughtful security automation. Let's dive into that a little bit. Relationship-wise, if I were to put on my developer hat and try to think about my collective interactions with security people over the years, one of the things that I think of is, if you've watched Monty Python, do you remember the bridge keeper from Monty Python? So if you haven't seen it, basically, if you want to cross the bridge, you have to talk to the bridge keeper, and he's going to ask you some questions. There's no reason that you would know the answers to those questions. But if you answer incorrectly, you get ejected into a lava pit and die. So that's kind of how developers look at security teams. It's kind of like, this person's trying to stop me from doing something, trying to stop me from getting where I'm going. They're going to ask me these crazy questions. I don't know the answers. How is this interaction supposed to work? So that's kind of how I view it. And then if I take off my developer hat, put on my security hat, and say, well, what do I think about developers? This guy comes to mind. So this is Dexter Tripp. He's a thrill show artist, and you'll see here he's balancing on a flaming tightrope. He also does stuff like duct tape fireworks to his chest and sets them off. And then he lets kids in the audience throw water balloons to sort of put them out. So security teams look at developers like Dexter Tripp, and they're like, you're doing all these crazy things. You're exposing the company to all kinds of risks. You're not thinking about all the bad things that can happen. And if we dive into a little bit more about what motivates these thoughts, I try to summarize developers and security folks with, if we could think of a mantra that might describe these groups. This is a good one, I think, for modern software development. If you're not familiar with this is from Facebook from a couple years ago. And the idea was, if you're not breaking stuff every once in a while, you're probably not being aggressive enough. You're not moving fast enough. And it makes total business sense to move fast as an engineer because you want to get customers, you want to beat competitors, you want to get market share. It makes sense. And when developers are successful, this is what it looks like, right? You get accolades, you get gold medals, you get your picture taken, everybody celebrates. What do security folks do, and what kind of motivates them? What's their mantra? I kind of think this is a decent one. I took this picture at a hardware store a few years ago. And of course, this relates to workplace safety, but it maps pretty well to information security, I think. Because what we're in the business of is we want to stop bad things from happening, right? And one strategy to prevent bad things from happening is just stop all things from happening, right? And that's how security teams kind of get that view of like the bridge keeper. We're trying to stop something from happening. Because for us, we don't really celebrate a lot in security. We have more of this. This is a good day for us, right? So like silence equals success. So then this is what we end up with, right? You have developers and security teams. They're obviously both really important, but do we just have to live with this constant kind of headbutting and uncomfortable and sort of suboptimal interactions, or can we move past that? And one of the things I think is interesting, certainly if you've watched any other sessions or if you watch the keynotes, everything that's going on now, today, at reInvent and in development in general, is designed to move things faster, right? No one is saying, hey, how can we do fewer deployments a day, right? Let's slow things down. Everything is moving faster, right? Like serverless and microservices and just cloud in general. But this is actually, so you could think that this could probably maybe even complicate the relationship even more, but I actually think this is actually what can enable us as security folks. Because ultimately, right, opportunities for developers are also opportunities for security teams, right? So when you go and you log into the AWS console, AWS doesn't ask you, hey, are you a developer or are you a security person? Everything that's there, we can use as well as security teams. And that's kind of my thesis for today, is I think if we take advantage of those opportunities that were provided now, and these are just kind of a general set of tools and practices and just almost like a mindset around high velocity development, if we take that and we combine it with a deep understanding of why security teams and developers have had a hard time getting along, if we combine those, we can actually, as an output, have really powerful tools that will improve security and improve those relationships. So I want to start just briefly with some of the design principles I mentioned in the intro of basically characteristics of what I would consider to be successful security automation. So the first one, this is one I feel pretty strongly about, is when we build security automation and security tools for developer use, we really want to integrate as much as possible with how developers are already doing something, right? We don't want to create a bunch of new tools and new dashboards that people have to go to. We don't want to interrupt the workflow, so we want to integrate. Next, there's probably a better word for this. I just call it security plus plus. This one's kind of a no-brainer, but if you can solve a security problem and at the same time improve some other dimension of the system, like availability or reliability, that's a really, really good place to invest in terms of prioritization. Transparency goes back to that idea of the bridge keeper and a developer view of security as like this opaque decision maker where you just kind of thumbs up or thumbs down and you don't really know why that decision is being made. So I think this one is really important. When you build tools, you want to make sure that how they're operating is very clear. It's very apparent to the developer or really the user of the tool. So it's the way that the decisions are made should not be confusing or hidden. We also want to be low touch and decoupled. We talk a lot about distributed development. You talk about microservices and people being able to iterate on their own speeds. We want to, as much as possible, stay out of the way of deployment, right? We want to be able to build our tools so they're low touch and decoupled from development process. And then really finally, this kind of, to some degree, ties all these together. Developers, they have a lot of really great tools at their disposal, but they also have to keep a lot in their brains to build successful services. And we don't want to add to that load for security. So it's great when developers care about security, but I really want to make the developer experience with security tools as minimal as possible, so things just kind of work. They don't, like you just opt in and things, you'll sort of get the benefits of it without having to think too much. So that's kind of what we're going to do today, is a little bit of maybe a journey or a roadmap. What we want to do is we'll dive into some specific examples of some of these problematic interactions between developers and security teams. And then we want to see how we can apply those design principles, we can apply AWS capabilities to solve those. And then hopefully we'll end up with happier developers, happier security teams. Security will be improved as well as just the overall system. So the first thing I want to talk about today, the first interaction, sort of three fun letters that all security people like and operations people as well. So I'm going to talk about SSL and TLS kind of interchangeably here. The differences don't matter a whole lot for what we'll talk about. But SSL, what I've found is that it's kind of a love-hate relationship for security teams. We love it because SSL provides a lot of good security benefits, right? It encrypts network traffic, it helps you authenticate clients and servers. But on the downside, there's a lot of operational problems associated with SSL, especially as you get to larger scale. I won't ask for a show of hands, but I'm sure some folks have potentially had an outage related to an SSL certificate expiring. I know that's happened to me. We're in good company though. It's happened to Google, it happens to Azure, happened to Instagram. So the nature of SSL certificates is when they expire, things break. And sometimes it's hard to figure out where all your certificates are when they're going to expire. So you have this problem where you're increasing security because you're encrypting traffic, but now you're creating yet another thing that can go wrong and that ops teams and developers have to worry about. Next is, you probably recognize this logo. This wasn't too long ago. This is Heartbleed. This is a really pretty nasty security vulnerability in OpenSSL from a couple years ago. And this is, so SSL is supposed to be a security benefit, but if you're familiar with it at all, it's had a pretty long history of pretty serious security problems, both in the protocol itself as well as implementations. So we've had this problem over the years of having to patch and having to change configurations because there's yet another problem with SSL. And then last, but certainly not least, how do you even create an SSL certificate, right? I mean, developers don't do this that often, and if you've ever used OpenSSL at the command line, it's not good. It's not a good thing, and it's not only complicated, but the choices you make when you're requesting an SSL certificate, those choices matter in terms of the security of the solution, and just the process of creating SSL key pairs and CSRs, that needs to be protected, right? If you're creating SSL keys on developer laptops, that can have bad outcomes. So you need to protect that. So we basically have these historic issues, right, where you have outages caused by expiration, you have vulnerabilities, you have complicated configuration. But now, what we have with AWS, we basically have new tools that we can use to apply to this problem. And specifically, we have API-driven configuration, right? So at Netflix, we tend to use ELBs, or elastic load balancers, to terminate most of our SSL. And of course, these are all configurable via APIs. Centralized management, right? It's just one place to do everything. You don't have to worry about all your different physical hardware and places where certificates could be stored. And then we also have machine-readable policies. And this is important when, a month from now, a year from now, when the next problem with SSL comes out and we have to create some new configuration. Because we can read these via machine, it's very easy for us to keep an eye on these. So what we did at Netflix to try to make this easier or to solve some of these problems, we built a system that we open sourced actually about a year ago. I think it was right before reInvent last year, called Lemur. You can check it out on our GitHub page if you're interested. But the goal with Lemur was just to be a one-stop shop for SSL certificate management. And what I mean there is you can go there to request the certificate, it will provision the cert, it will deploy it, monitor it for you, it will make sure it's backed up so you don't have to worry about it. And it will also help you identify problems in your SSL configuration. And the nature of the way we built Lemur is that it has a plugin architecture, so you can use basically the configuration you need for your environment. And we've had a lot of interesting external PRs to Lemur to actually extend it. So I'm just going to walk through a real simple interaction. A real common thing to do at Netflix is somebody builds a service, they build an app, they want to do the right thing, so they want to put SSL on it, right? They want to encrypt the network traffic. So this is just a screen from Lemur, and all we really ask you to do is put in who's the owner, and we ask for a distribution list here versus a person, because we want to know who do we contact if we have a configuration issue, who do we contact if it's expiring, and we need to renew it. We also allow you to choose which certificate authority you use. So you can use an external certificate authority like VeriSign. Lemur also supports DigiCert as well as Let's Encrypt. You can use an internal CA like a private PKI if you have one. And then you just put in your certificate name. So here I'm creating a certificate for a system called jason.netflix.com. And then what you do, this is just kind of like one screen cut in half. We have this idea of destinations because you don't want to just create an SSL certificate, you actually want to use it. So destinations for us, I mentioned we use ELBs primarily. So destinations are basically the different AWS accounts that you might want to deploy the certificate to. Right? So maybe you have a test account or a production account, anything like that. This is basically a box that lets you choose which accounts you want to send those to. And then you just click create. And what's going on behind the scenes is pretty simple. The developer goes to Lemur. What Lemur does is it creates the private key and the public key and makes sure those are stored securely. It also creates the certificate signing request, or CSR. From there, depending on who the CA is, who the certificate authority is, Lemur then goes out, requests that certificate, and then the CA will issue it, return it to Lemur. And then what Lemur does is deploy it to your AWS accounts. So basically, you go to one page, you fill out a couple of fields, click create. What Lemur does is it creates the certificate for you, all the private keys, and deploys it to AWS. And then it's there, so if you've used ELBs, it's there now ready for you to deploy to your load balancer. So it's really like, like a 20 to 30 second operation. You don't have to worry about the security of your laptop, anything like that. You don't have to worry about losing keys. Lemur takes care of it all for you. And one of a pretty common use case for Lemur at Netflix, I think one of the things that's interesting about development these days is it's not just pure engineering, it's a lot of integration with third-party services. So Lemur allows you to also import certificates that may not be yours. So you may want to monitor the SSL health of your partners, and Lemur can do that for you. And this right here is just the import. So you basically just paste in the public certificate, and Lemur can track it for you in terms of expiry. So if you're familiar with things like SSL labs or other tools that will kind of give you a sense of what your SSL configuration looks like, Lemur helps you with that as well. And I think the universal sign now for something is wrong is this kind of red triangle there. So this is Lemur telling you, you have a problem with this load balancer here, right? So if you click more and we dive in, what Lemur is telling us is you're using TLS version 1, and as it happens, that's a deprecated protocol. So it recommends that you update it. So it kind of takes care of the certificate management as well as the endpoint health. So just takeaways there. So what we see here is APIs now give us opportunities, right? And we can focus our automation efforts on investments that are really targeted towards problems that have been around for a while and have been pretty difficult to solve. And then we have this outcome that we call like the security plus, where we're improving security, but we're also improving availability, right? Because we're much less likely to have outages related to certificates expiring. So the next thing I want to talk about is permissions management and access control. This is also a historically problematic kind of interaction where you have developers asking for permissions and security teams have to grant those. If you think about it at its most simply, and this is kind of at the academic security view, it's really quite simple what we're trying to achieve for security people. We want this idea of least privilege, and that's just, we want to give you the rights that you need, the permissions you need, but we don't want to give you more than that, right? Because anything you provide above and beyond what's needed is a potential for some problem to happen. But in reality, right, we know that it's not as easy as that. And I like to use a couple of comparisons to kind of talk about why permissions management is so difficult. The first one is a quote you're probably familiar with this quote from Grace Hopper. Of course, she wasn't talking about AWS permissions here, but I think if you sort of parse this quote, you kind of get a sense it does relate to security, right? The idea here is that if you do ask for permission, there's a risk that that permission will be denied, right? It can delay things, right? So instead of worrying about that, just sort of, kind of bull in a china shop and just go and do things. Maybe something breaks, and this kind of goes back to that Facebook slogan, right? Move fast and break things. Like, just go ahead and do it and sort of worry about the consequences later. And then that kind of brings me to my next analogy that I used to talk about access control. And that's Goldilocks in The Three Bears, if you're familiar with this fairy tale. Basically, Goldilocks is this little girl. She's going throughout the woods, and she comes upon this house that the three bears live in. And it's a mama bear, a papa bear, a baby bear. And she goes through and she sleeps in all their beds till she finds the one that fits her just right. And she eats their breakfast till she finds the one that's just the right temperature. She sits in their chairs, same thing. And at the end of the day, so Goldilocks is the developer in this case. At the end of the day, the developer gets what she wants. The problem is the bears come home and they're like, what's going on here? Like, my beds are slept in, my breakfast is gone, my chairs have been broken, but so you kind of have this wake of destruction in the path of trying to get what you want and get what's right. So I'm going to take a leap from Goldilocks to AWS Permissions Management. So you'll have to take that leap with me, hopefully. So when I think about AWS and why it's so powerful and why if you think about even the way that reInvent has grown, there's so many people here. It's because it's not really about can I launch an instance and do something, right? You can launch an instance and you can combine it with, say, Dynamo or a queuing service or email service, and there's all these things that you can piece together that you used to have to worry about, but now you just kind of plug it all together and you sort of create some magical solution. So that's basically what we do at Netflix. We put it all together, and then all of a sudden there's TV shows on the internet. So that's where the magic is. But if you've used IAM, which is AWS's kind of permissions management system, it's a pretty sophisticated policy language. And so this number is already out of date because, of course, there have been lots of different service releases. But there are, several thousand individual API calls, and permission-wise, you can say yes or no on each of those with lots of different conditions. So it can get complicated really, really quickly if you're trying to do the right thing and just give that least privilege. And as I mentioned, they're released all the time, at a much higher velocity now at reInvent. And just more generically around permissions management, it is difficult to achieve in practice. And what we've had historically, if you wanted to set up a system with least privilege or the right permissions, you had to configure your OS, you configure your file system, you configure your database, your application server, all these different places that you had to tweak to get it the right way. And you ended up having pretty low visibility. You didn't know if what you were doing was actually right. So if I give you permission to do something, do you ever use it, right? Because what we tend to find is that if you give somebody too many permissions, no one complains, right? If you give them too little, someone's going to come knocking on your door because you've caused a problem. So with AWS, what we have now is just one place to do all your permissions, right? You can manage them all in one place. That's a ton of benefit there. It's all API level, so very granular. It's API driven in terms of how you manage the permissions. And we have visibility. So if you've used things like Access Advisor or CloudTrail, you know that you can see whether or not those permissions are being used. And it really allows us to move more towards this idea of infrastructure as code, where we can consider a policy like an IAM policy as code, right? And we can manage that in our source code repository, and we can manage changes to it and version it. So this is kind of the history, right? And now what we have available to us. So how we applied that at Netflix was we built a system called Repoman. And if you're familiar with Repoman or with what a Repoman is, it comes from the car loan business. So if you buy a car and you pay your car payments, then you get to continue to drive your car. If you don't pay your loan, then the Repoman comes and repossesses your car. So what Repoman does in AWS is we'll give you permissions. If you don't use the permissions, we're going to take them back. So that's kind of the sort of quick summary. So this is the UI here. And it's basically, the way I think about it, it's an IAM-focused view of CloudTrail and Access Advisor, right? So this column here are different IAM roles. And what you'll see here, what Repoman is telling us is that you have a bunch of permissions that you've granted this system, but the system's not using it. You see that first one there. There's 553 permissions that have been granted, but 348 of them haven't been used. And then Repoman is also useful as a general troubleshooting tool. If you're getting access denied errors, they'll bubble up here. So you'll know, hey, this role is trying to do something that it's not allowed to do. And that can be helpful for just troubleshooting. It could be helpful for identifying potential incidents. And this is kind of, when you drill in, you'll see here, you have both a CloudTrail view and an Access Advisor view. And it's telling us, these are all the different API calls that this role has made with a count. So this is for SecurityMonkey, which is another system that we open sourced. Basically monitors your AWS configuration. But these are all the APIs calls that have made. These are all the errors that have occurred. These are non-access denied errors. And then these are all the access denied errors that SecurityMonkey has seen. And then this is the Access Advisor view. So if you're not familiar with Access Advisor, I think this is a bit newer than CloudTrail, but it's more of like a service level view of whether or not something's been used. So you can see here, the last time that this role used Elasticsearch was 7 months ago. So you kind of have it's not at the detailed API level view. So you can use Repoman to just kind of troubleshoot or get a view of what's happening. You can also use it to tighten things down. So this is the kind of view you get when you go to do that. You'll see here it's telling us we have 253 permissions, and 163 of those are removable. So if you look at the details, this one it's saying, well, we can keep that one. Let's remove that one. But here's one. This one's a maybe. And if you click on this one, it would give you more details. So Repoman basically has some rules built in of how it determines whether or not something can be removed. And if you're familiar with CloudTrail, you may know that not every API call actually shows up in CloudTrail. So if we don't know for sure whether or not we can remove it, we'll be conservative and keep it, but we'll give you the details. So for example, we may not know if a call shows up in CloudTrail, but if we've never seen that anywhere across the entire environment, that might give you more confidence that you could remove it. And then what you do here is you click Promote to Template. What Repoman will do is create a new policy that only includes the ones that you wanted to keep, and then basically stores that away, again, that kind of infrastructure as code model. It stores that policy as a new version of this access policy, and then you can then roll it out to your environment. And we'll talk about how we do that rollout in just a bit. So what Repoman lets us do is a low-risk access reduction, and this is a really, really important thing. This is for folks that have worked in security, I have done this in the past. I'm not proud of it. But one of the ways that security teams have historically done changes is we'll say, hey, let's just turn this off and see who calls us, right? If you think about it from the person who gets impacted, that's not really a great, this is why we have bad relationships with developers, right? Because somebody's just trying to do their work and all of a sudden it stops working. They don't know why. They dig in their logs for 5 hours and see an access denied message, and they're gonna come and bug you because this worked yesterday. So this helps us avoid that problem, right? We're not just turning something off and hoping nothing breaks. It's transparent, it's versioned, people can know what's happening, why we're making the decisions, and it does this kind of security plus where it's enabling innovation, it lets people move fast, it lets people, high velocity development, but it lets us be secure as well. So all this can happen in the background. Developers don't even need to understand, they don't even need to know that Repoman exists, and in the background it can kind of be shrinking down those permissions. So that's what we generally try to do with IAM permissions is we try to developers shouldn't need to worry about that. That's how we handle a lot of things at Netflix. Most of our developers don't need to be real hands-on with AWS. You can think about people who are doing machine learning or recommendations, or they want to build their product, their feature. We do have a set of teams, more infrastructure teams, that are much more hands-on with AWS. And we wanted to be able to provide a mechanism for those more like power users to be able to interface and request different IAM permissions. So we did that via this system called Rollie Pollie. So Rollie Pollie is kind of the infrastructure for managing those IAM policies as kind of infrastructure as code and rolling those out. And what we did to kind of optimize the workflow was we integrated it with ChatOps. And ChatOps is kind of, I think it's a relatively new term. So just kind of a little bit of basics. It's, as you see things like Slack and HipChat proliferate, more and more operations teams are starting to build like API integrations so that they can be within their chat client and kind of make things happen and just make their work easier. So just some basics. We have a we have a bot in our chat room that we call OtterBot. This is like a real simple chat ops type thing. Basically what happened is somebody created us a Jira. And so Jira doesn't know who's on call. So OtterBot checks in our PagerDuty, see who's on call, and then auto assigns that. So this is kind of a real basic chat ops. This one is another chat ops kind of integration where, we work 9 to 5, we try to keep bankers hours. So we want to let people know if they come into the chat room, into our help room and say, hey, I need help with something. Let them know, hey, this is not being actively monitored. If you really need us, go ahead and call one of us. So that's what OtterBot can do for us. And then a more AWS specific example, if you're doing an investigation, you're doing troubleshooting, you see instance IDs and IP addresses, you want some more information about that instance. So OtterBot can tell you, what is the app using that, what account is it in, what's the location in terms of region and availability zone, what security groups, all that kind of stuff. That's kind of like the basics of ChatOps. And what Rollie does is it provides an interface for developers to basically issue PRs against those IAM policies. So if I'm, for example, a power user and say, hey, I need this, or maybe a new service came out at reInvent and somebody wants to use it, they can actually submit a pull request against whatever IAM role or IAM entity, and then we can review that. So how that works via ChatOps is OtterBot basically keeps an eye on Rollie jobs. And you'll see what's going on right here is that OtterBot has noticed that there's basically a change. Somebody has submitted a pull request against this particular IAM policy. This one's called Swordfish. And what happens is then we're notified in the room, and you'll see there Ben is our on-call, and he's just doing a describe against that. And then OtterBot returns, okay, well, here's some of the information about what's going on there. And then basically what Ben can do, if he thinks that change is okay, he can click approve, or not click approve, but basically issue an approve command. And what that does is it will then merge in that pull request. But because managing permissions, that's a sensitive thing. So what we do is we integrate that with multi-factor authentication. And what happens is then Ben is sent an MFA challenge to his phone. If he clicks approve, that pull request will go ahead and get merged in and then sent out to the environment. So benefits of Rollie, and this is something that we've gotten quite a lot of feedback on, is people like that it's an engineering native workflow. Right? Developers are issuing PRs all day. So if they have to do one to get permissions, that's a completely natural thing to do. And it's very transparent, of course, with code reviews and things like that. It lets us be automated, secure, consistent across the environment. We're not making changes kind of on the fly. Everything is recorded. And then it also, just by using, really the more that you invest in ChatOps, I think the more valuable it gets. So it lets whoever is on call, allows them to make changes more quickly without switching around to a bunch of different systems and doing context switching. So the next thing I want to talk about is really more of like a meta topic or like a meta relationship between security teams and developers. And this is the idea of just security in the development lifecycle. Basically, if you're creating a new application, right, and you have some notion that you would like it to be secure when you're done, there's various sort of things that you would do as you're developing it to get that outcome. And as it happens, there's actually quite a lot of information, and there's a huge body of knowledge out there around how to develop software securely. It's actually, it's pretty well done. A lot of it was driven by Microsoft via its Trustworthy Computing initiative. But the problem that we have now, this is actually a tweet from a presentation. I think this was like 2012, actually, but I always save it because it's still applicable. So if you can't read that, that's basically a gravestone, and it says, traditional application security, we hardly knew you. And this is very true because we had spent like 10 or 15 or 20 years creating all these practices around how to create secure software The problem is all of those practices are aimed at traditional development processes, right? Meaning linear, monolithic, and even to some degree, securing a product that you're going to ship to somebody, not an online service. So we kind of had this idea of how to do it right. That's not to say that we actually did it right, but we had the knowledge to do it, but then everything was kind of, the apple cart was upset as everything moved to cloud and agile and, continuous deployment. All those kinds of things really complicate traditional security in the development lifecycle. But Microsoft came to the rescue to some degree. They actually revisited their guidance and then created a separate SDL for security in the Agile lifecycle. But the problem is, this is still 17 steps across 7 different phases. I don't know how development works in your organizations, but my security team is not big enough to engage with 100 different teams at this level of detail, right? It just doesn't. The resources don't exist. So we basically need to take that knowledge that we had and figure out how do we apply that to modern development, specifically high velocity development, distributed development. And I want to walk through a couple of examples of pretty typical interactions in the development lifecycle. The first one is what I call application risk assessment. And with an application risk assessment, ideally what the security team can do is early on in the process, when somebody has an idea, hey, I want to build, some new system to solve some interesting task. The security team kind of wants to like red, yellow, green in terms of how critical is that system, how risky is that system, and then we want to use that decision to drive what processes we then apply to it. So does it need a code review? Does it need a penetration test? Those kinds of things. But the problems, there's a lot of problems with the process. One of them is that I've done this before, almost always the risk assessment is a spreadsheet. And basically the spreadsheet is this from the security team. It asks a bunch of questions and the developer or the product owner answers those. And then based on those answers, that's how you get your score. But the problem that we all know, humans, they lie, they can misinterpret things. You probably know there's entire sciences around, like how do you effectively ask somebody a question so you can get the right answer? And security people have not studied those things, right? So we'll ask things that, this makes sense. Like, are you accessing sensitive data? And it's like, what is sensitive data? Is it social security number? Is it credit card? So there's a lot of problems with the process. It's better than nothing, I would say, but it can kind of give you a false sense of security. It also tends to be one time, meaning we'll do this at the beginning, but then it never changes, right? But we know that systems change over time. Maybe, hey, we didn't used to process credit cards, but now we do. So that will change your risk profile quite a lot. But if you're only doing this assessment at the beginning, you're going to miss out on that. And then also, it really assumes that you understand where all of the demand is coming from, right? That you know, that you manage how projects happen. And that's just not the case anymore, right? We have teams that are, when you have an idea, when a developer at Netflix has a great idea, I'm not the first person they come to talk to. Right? It might be great if they did, but they want to go and experiment, and before you know it, something's in production. So there's not really this defined process of how you sort of take something live, and that's really part of what enables high velocity. So with AWS, we have some new advantages, though. We have this idea of objective observability, right? We can see how a system is operating and then make decisions based on that. So it's kind of like, to me, inventorying is one of the most important tasks in security. You have to know what's out there. You have to know what you're responsible for before you make decisions. And AWS provides you that ability. Like, you can't really hide in AWS, right? You can't launch an instance that is hidden from a describe instances call. It's not like in the physical world where somebody can be running something in production that's hidden under their desk. So we have much better ability to observe what's happening. And of course we can do this on an ongoing basis. We don't just do it at the beginning. We can see how things change over time. And even a bonus, not that we don't like to talk to our developers, but there's no humans required. We can make all these observations without involving developers, without requiring that kind of intake. So that leads to this system that we call Penguin Shortbread, and kind of a summary of it is just an automated risk analysis system that's really optimized for microservice architectures. So it's designed to look at a large distributed system and help you make decisions about what's the most important from a security perspective. And the way it works is it's pretty simple in terms of the theory of operation. It basically looks at different dimensions of the system and then makes decisions about it. So for example, we're pretty heavy users of auto-scaling at Netflix. So does your app auto-scaling group, does it have 3 instances or does it have 3,000 instances? We look at dependencies. We look at things like connectivity to sensitive systems. Like, does your system connect to the payment card vault or to our subscriber database, those kinds of things? Is it accessible from the internet or is it an internal system? And then also we use various different AWS accounts, and some of those accounts house more sensitive things. So based on what account your system lives in, we can make more decisions there. And really what happens, as you would expect, we basically just develop a risk scoring system based on those observations and then just use that to prioritize efforts. Because one thing that's common with all security teams is you don't have enough resources to do everything. So you have to make decisions about where you're going to spend your time. And you want to do those in as educated a way as possible. So this is kind of like the heart of how Penguin Shortbread works. This is an example of what we would call an application risk metric. This one here we call dependent applications. And what it's doing is just asking a question, how many applications depend on this one? And it's basically, if you think about it, if your system has like 500 other systems depend on it, it's kind of a proxy to criticality to some degree. It's not perfect, but the idea is if you make a lot of these observations, you can then aggregate them to make a more informed decision. And there's the algorithm right there. It's just basically checking how many dependencies it has. And then here's your score. So the way you would read that is if you have between 50 and 100 dependencies, we're going to call this a high risk on the dimension of dependent applications. So again, what we would do is we would observe as many different things as we could and then create that as an aggregate score. And this is what you'd see in like a roll-up. Those are the different metrics on the left-hand side, and then different scores across regions and across environments. And then what we would do as a security team is you kind of like think how you would sort a spreadsheet, right? Well, let me sort of sort these from highest risk to lowest risk, and that gives us a view of where we should be spending our time. And so we developed Penguin Shortbread first, but what we found we wanted to also do was make that information more available to developers so that they could prioritize things. So for whatever portion of their development budget that they're going to devote to security, we wanted them to be able to do that in an informed way. So we created a kind of a companion system that we call Security Brain, which is kind of like an upside down view of all the kind of vulnerability and pen test information that security teams might use, and we expose it to developers. And the way you read this, one of the things that we found to be really useful when we build security tools is we overlay this idea of the organization. So you can see here, basically if you read that, that's just kind of our org chart, starting with our CEO on down to me. And then basically what I can view here is all of the different apps in my organization, in all the different apps that my team has created. And then above that, Yuri, who's my manager, could see his whole organization. Neil, who's our chief product officer, could see his whole organization. And then what you have down here on the right is the security risk rating and the security grade. So the risk rating is coming from Penguin Shortbread. It's basically saying, hey, here's how sensitive we think your app is. And then the security grade comes from our different assessment tools when we're finding bugs and things like that. We expose that as a grade to the developer. And then the developer, what they would want to do is focus on the highest risk applications that have the worst grades. So they don't really have to think about, what JIRA do I fix first? It's like just work down. So it lowers that kind of the context that they have to keep in their brain. So benefits there, low touch, it's ongoing. Nobody needs to know this exists, this process exists. It's objective, it's transparent. No one is wondering how we're making the decisions. You can see all the different algorithms that we use to calculate the scores. It's a real simple prioritization to help reduce the cognitive load and let developers be more effective. And the last thing I want to touch on briefly is kind of a subcomponent of security in the development lifecycle is the idea of security requirements. And security requirements have been pretty problematic for a couple of reasons. One, I think, is that we've just been ambiguous about, how do we define what security means for an application so that a developer could basically implement against that. And then it's also difficult to verify, right? A lot of times we might say, hey, protect your application from cross-site scripting, right? But it's hard to actually verify that has happened. So with AWS, we now have a couple of things that we can take advantage of. The first is that we have an API-driven implementation. So to the extent that we have security requirements that are AWS related, we can make sure that those happen via API, and we can also evaluate those. So it's not difficult to see if those things are met. So the way we do this at Netflix is actually through an existing program that we had that we call Production Ready. And what we wanted to do is we wanted to take the requirements that we had and sort of push them into this program so that it's easier for developers to understand what we expect of them. So Production Ready is actually, it's an outreach program that our SRE organization created and they manage. The idea is that we have a number of years of experience building large-scale systems, running in AWS, and we kind of understand how you should be doing that. Right? At Netflix, we have this cultural idea of freedom and responsibility, so we tend to not force people to do things, but if we know something works, we're going to let you know about it. So this kind of goes back to things like Chaos Monkey and the Simian Army. So we're not necessarily going to tell you how your system should be reliable, but it's going to need to survive random instances dying and things like that. So different kind of practices like deployment practices, monitoring, testing. And what we do from there is create automated scoring. And there's really two objectives. What we're trying to do is uncover risk and then also reward excellence. So the way that the culture works, that freedom and responsibility, we kind of have this idea of kind of informal peer pressure. So we're not going to make you do something, but like with Production Ready, if your Production Ready score is really low, basically what that means is, hey, we know all these things that you should be doing, but you're not doing them. We're not going to tell you that you need to raise that score, but if your system has outages, if you cause problems, if it has poor performance, you're ultimately going to be responsible for that. So just make it easy and just kind of sort of join in. But it does, if your production ready score is high, like if you have 100%, basically what that means is everything we know about running successfully in AWS, you're doing. So it's kind of like a safe harbor to some degree. You're doing everything we know you should be doing. So some of the examples of security-specific measures that we have. So we have ideas and requirements around how we want security groups to operate. We have similar ideas around IAM roles. So we looked at some of those in Repoman and in Rollie, Pollie. There's also non-AWS specific things that we can put into production ready. So for example, it's good to not store passwords in your source code. So we have different checks to kind of identify that. And basically the idea is, if we find a password in source code, then your production ready score for that one is going to be lowered. But if we don't find it, then it will be higher. And that's kind of how it works. This is a view of the dashboard. This particular app scored a 77%. And you'll see on that left-hand column, those are the different measures. So alerts, like auto-scaling, canary, chaos. And basically that bar, the horizontal bars are over time how you're doing on that particular dimension. So you'll see, as of that date, that week of August 28th, on the auto-scaling dimension, this particular app got a 91%. So basically, we have what's encoded in there. There's a bunch of rules that we have around how auto-scaling should be configured, how your policies should be configured, and that kind of gives you a sense of how compliant you are with those rules. So benefits there, one of the really great things was it already exists. Right? We didn't have to invent our own program for how we're trying to evangelize how to do security in AWS. We already have a program for that, and we just inserted our security requirements in there. It's simple to evaluate compliance, right? It's not ambiguous. It's either on or off. And really, what we found is the idea of the paved road. It really paved road really, it minimizes how much a developer has to think about, right? Because a paved road, the sailing is a little bit smoother. And then finally, it's easy to extend. As we have new things that we want to look for, we just add them to the production-ready framework, and then it gets checked for us and gets tracked over time. So just wrapping up, some quick takeaways. I really do believe that security teams should be taking advantage of these features, right? We shouldn't leave all the fun to developers. We want to take advantage of what we have. And if we want to use that history to provide, we want to learn from the history, we also want to use it as input to our development. And then finally, we want to aim for security that's more ubiquitous, but is also can potentially improve some additional characteristics of the system. I think I might have time for just a couple questions and just a reminder to please complete evaluations. Thanks, everybody.